In this video, we are going to talk about how to find missing angle measures in a right triangle using trigonometry. So if you see in this vocabulary here, we're actually going to be using the three trig functions, tangent, sine, and cosine. However, we'll be using the inverse of those three tangent functions. So in this video, I want to talk a little bit about what that means. So we see here it says that if the tangent of angle A is BC divided by AC, which is opposite over adjacent, then the measure of that angle, angle A, would be the inverse tangent of the ratio of the opposite over the adjacent sides. And the same follows for inverse sine, and the same follows for inverse cosine. Whenever you want to find the measure of that angle, you take the inverse sine, inverse cosine, and you still use the same ratio of the two sides. So it's important to note that the expression tan to the power of negative 1x is read as the inverse tangent of x. So whenever you see that little exponent of a negative 1 right after the trig abbreviation, you know you're dealing with the inverse trig function. So let's explain what this means. So in example 1, we have angles A, B, and C, and they are acute angles. And we're supposed to use a calculator to approximate the measures of angles A, B, and C to the nearest tenth. So nearest tenth means 1 decimal place. So I'm going to do example A off to the side here. I'm going to write tangent of angle A equals 3.29. Now the whole idea here is that we want to get the measure of angle A, just capital A here, by itself. And right now it's not by itself because it's being taken the tangent of. So just like the inverse of multiplying is dividing and the inverse of adding is subtracting, well, the inverse of taking the tan is taking the inverse tan. So when I take the inverse tan of the left-hand side, inverse tangent and tangent cancel each other out, and I'm left with A. Okay? And then don't forget the rule of solving any equation. Whatever you do to the left, you must also do to the right. So I know I don't have a lot of room here, but I'm basically still going to take the inverse tangent of 3.29. So that means the measure of angle A is the inverse tangent of 3.29. Now, don't get confused because you see letters here. This is a number. Inverse tangent of some measurement is a number. So this is where your calculator comes in handy. If you look above the three trig buttons, sine, cosine, and tangent, up above you see the inverse sine, the inverse cosine, and the inverse tangent, and they're written in yellow. So that means you have to hit your yellow second button in order to use those functions, and it might be different on your calculator. So if I want to figure out what the inverse tangent is of 3.29, I'm going to hit second tangent, because that'll give me the inverse tangent, and you see on my calculator it has a little negative 1 exponent, and I'll type in here 3.29, and I'll close my parentheses, and I'll hit enter. This is the value of A. So remember, we're rounding to the nearest tenth of a degree, so that's 1 decimal place, and since 9 is above 5, I'll round this up to 1. So that means that A is 73.1. So the measurement of angle A is 73.1. So over here to the side, I was showing you really what's going on, why taking the inverse trig function of a trig function cancels the two out, and it leaves you with the angle that you want to solve for. And that's essentially what we'll do down here for B and C. So to find the measure of angle B, well, if sine of B is 0.55, then that means that the measurement of angle B is going to be the inverse sine of 0.55. And that comes out to be, I'm just going to erase this work on the side here so that we have room. You should leave it on your paper, but I'm running out of room. So the inverse sine of 0.55, inverse sine of 0.55, is 33 point, I'll round up to 4. So 33.4. And lastly, for the cosine of C is 0.87. Well, to find the measure of angle C, you would inverse cosine both sides. So inverse cosine of 0.87. And going to my calculator, inverse cosine of 0.87 gives me 29.5. So this is how you would solve for missing angles when you are given a trig function and using the inverse trig button on your calculator. Example 2, finding angle measures. So this example wants us to find the measure of the two acute angles given, measurement of angle Q and the measurement of angle R, and they want us to round to the nearest whole degree. Okay. Measurement of angle Q. So angle Q is up here, and the only two sides that were given are the adjacent and the hypotenuse. Yes, we could technically figure out what this opposite side is, but let's save ourselves some work and just use what we're given. So we know that the trig function that relates adjacent to a hypotenuse is going to be the cosine. So I know that I can write here that the cosine of angle Q will equal adjacent over hypotenuse, which is 6 over 15. Now, I can say that I want to find, well, what Q is. So remember, as I did in the last example, I'm going to take the inverse cosine, and whatever I do to the left, I must do to the right. So the inverse cosine and the cosine cancel each other out, and I'm left with Q. And Q is going to be the inverse cosine of 6 divided by 15. So I definitely don't expect you to know what this is. I want you to go to your calculator and I want you to find what the inverse cosine of 6 divided by 15, close your parentheses, is. And we get 66.4, and they said to round to the nearest degree, so I'll say 66 degrees. And that's the measurement of angle Q. Now, to find the measurement of angle R is over here in green. So we're given, in relation to angle R, we're given the opposite side. So 6 now is the opposite side of angle R, and again the hypotenuse. So the trig function that relates the opposite side with the hypotenuse is going to be sine. So I'm going to set it up here that the sine of angle R equals opposite, which is 6, over adjacent, which is 15. Now if I want to find out what R is, I'm going to inverse sine the left-hand side, and I'm going to inverse sine the right-hand side. So inverse sine and sine undo one another, and I'm left with R equals the inverse sine of 6 over 15. Now to figure out what that is, I'm going to go to my calculator and do second inverse sine of 6 divided by 15. And this gives me 23.6, so I'm going to round that up to 24. And I'm going to say the measurement of angle R is about 24 degrees. So here's page 1 of examples 1 and 2, how to find angle measures using this inverse trigonometric function. So I want you right now to flip to the back, and I want you to try example 3. So I want you to hit pause at this time, and I want you to do example 3 on your own. Figure out which trig function relates the angle with the sides that are given, and use your inverse trig function button to solve for the 3 missing angle measures. When you think you are all done, go ahead and resume this video to check your answers with the answer key. So pause now. Okay, so now you have the 3 answers shown. For letter A, x should have been 44.4, For letter B, y should have been 48.6. And for letter C, z ended up being 26.6. I know that the directions didn't specify how many decimal places. I chose to just round to the nearest tenth. If you chose something different, that's completely fine. So I'm going to keep moving on to the next example, example 4. Example 4 wants us to draw and label a triangle for which you could use the following equation. So they don't want us to actually solve. They just want us to draw a triangle that literally represents the situation. So I'm going to draw a right triangle just because I know we're dealing with a right triangle here if we're dealing with trigonometry. And we're given that the inverse sine of 3 divided by 7 is x. So I know x is my angle here. I'm going to call x my angle. Now I know that the sine relates the opposite over the hypotenuse. So if this is x, the opposite side must be 3, and the hypotenuse side must be 7. Now I know that this fits my situation because, again, this x is representing the angle. And the reason I know that is because I'm given the inverse sine function, meaning that in order to solve for this angle, I had to take the inverse sine of the ratio of the two sides. So the inverse sine of the opposite side divided by the hypotenuse side would get me angle x. And that's it. This is literally all I want you to draw for this scenario in example number 4. And the last example here is labeled as modeling with mathematics. So this one says that we pretty much have a word problem here, and we have to solve for the missing angle. And the missing angle is right here, as you see the question mark. So we're still using trigonometry, but we're just modeling it with mathematics in a word problem. So reading this, it says, a person whose eyes are 5 feet above the ground. So I'm assuming the person is right here, and their eyes are 5 feet above the ground. They're standing on the runway of an airport 100 feet away from the control tower, and that's represented right here in the distance in yellow. They observe an air traffic controller at the window of a 132-foot tower. So this is in green here, describing the height of the tower. And they're asking about the angle of elevation. I highlighted that in blue because this is the angle of elevation. Angle of elevation is just referring to what's the angle at which I'm looking up at something. So the word elevation means looking up at something. And then they want us to round our answer to the nearest degree. Okay, so we need to set up a triangle that represents what we're doing here. So I know I have a right triangle. I'm going to redraw that because that was a not very good drawing. And I know I have a right angle here because it's given to me in the diagram. And I know that this horizontal distance down below is 100 because the distance from the person to the tower is 100. Now, I know that this is 132. The height is 132. However, keep in mind that the person is 5 feet, so there's all this space here that gets lost. Meaning that the height is not actually 132. The height is actually going to be 132, take away the 5 feet at which the person is standing and where their eyes are at. So when you take 5 away from 132, you actually get 127. So that means the height of this triangle is 127. And then the angle of elevation is right here. I'll call that x, just because it's unknown and I don't want to use a question mark. So now I need to think about, okay, well, which trig function relates the opposite with the adjacent side if I'm trying to solve for angle x? So right away you should think of tangent. So this means tangent of angle x equals opposite over adjacent. So this is the trig ratio setup. And then to solve, you just take the inverse tangent of both sides. So x is going to be the inverse tangent of whatever 127 divided by 100 is. So going to my calculator, the inverse tangent of 127 divided by 100, and that gives me 51.7, so the angle of elevation is about 52 degrees. And that is the answer to this problem.